Welcome back to another episode of Composites Weekly. On today's episode, I have Joshua Shires. He is the CEO of a company called Fyous, Fyous.com. That's Fyous.com. They're working with a technology they call polymorphic moulding. And it is basically it's automated, rapid shape-shifting molding technology. So if you can imagine, if you could take a 3D model that has been processed, they run it through their technology, the polymorphic molding machine, and it actuates pins that shift into the shape that you're trying to mold. So Joshua's going to probably come on and he's going to explain it a little better than I can, but it's fascinating. And some of the benefits of this technology that they're introducing is that it enables a molding tool that can be used in an unlimited number of geometries. You can create custom-made products in a cost-effective manner. You can go straight into production after a prototype has been approved. And so these are just some of the benefits. We've got the video displaying. And Joshua, thank you for spending some time on the podcast this morning on Composites Weekly. Appreciate your time today.
Well, thank you very much, Jonathan. It's a pleasure.
So I don't even know where to begin. I'll probably start with yourself because you're the CEO of the company. So maybe you could talk about yourself and then we can get into the technology. From what I understand and just reading on your website, this stuff's been patented for a long, long time. I mean, for probably a century, but you guys are taking it into a technology that can be utilized for our industry. So maybe start with yourself, your background, and you look like a pretty young guy. So I'm just curious of where you've been before Fyous, and tell us about yourself first.
It's very complimentary. I'll take that one home with me. Thank you. I'm Josh Shires, CEO of Fyous. I've been in business a long time, since I was like 20 years old.
Yeah.
I'm 34 now. So can't claim to be young anymore, but I found
it's relative, right?
yeah. Spring chicken, if you're in the 30s. I previously founded a company called Mouse Products, which made phone accessories. Mm-hmm. And I was able to sort of use that to fund this company Fyous, and it also led me to spending a lot of time out in China and just seeing how difficult it was to make products and make molds, and time to market, and the amount of waste. Because we made phone cases, a lot of phone cases, and obviously the tooling would only last a year because new phones would come out. And there's a picture floating around somewhere where I'm behind all our tooling that we've made over the years, and it's insane the amount of energy and waste that went into that. So
talk about the patent technology, because my understanding, it's not a recent type of application. It's been around for some time, but has just never been utilized.
So when I was looking for ways of like creating molds faster, I came across what they call reconfigurable pin tooling, which has been around for like over 150 years. Like some of the first patents were in like 1863 or something.
Right.
And they used it for making big ship panels, which were just like big screws, basically big pin screw pins.
Sure.
That they would set to heights and then form big sheet metal over it. But then if you sort of follow the history of all the patents, as you call them, basically no one seems to have ever commercialized it and made it like scalable. It's always been like R&D or, sort of just ideas around it. And so I think, I believe we're the first ones to ever sort of make it affordable and scalable and to such a high resolution as well. So no one's ever sort of been able to do pin molds, as they call them, or reconfigurable pin molds to less than like a sort of 3-4 mil diameter pin, whereas we're down at 0.8 with 1.4 millimeter spacing. So And that means if you like look at the tooling from a meter away, it just looks like a solid piece of metal. It's that highly
you can't. So it's very difficult to see the separation, like with
exactly
like all the pins. Yeah. Like the gaps in between, because I guess it's just so tight in there.
Yeah.
I mean, we sit on the video, you can see some representation, kind of a rendering representation of how that would look like. But you've got some videos on YouTube, and we'll be sharing those on our show page. So you mentioned, one of the things you went, looking at phones, obviously the casings, they're always changing. But this can be done for, I guess, any size tool or any size mold that you're needing to build, theoretically.
Theoretically, yeah. So you can take as many of these, what we call RPTs, right? Reconfigurable pin tools.
Sure.
You can take as many as you want and make massive molds.
Right.
So this is something we're going to be looking into. So we have our machine, what we call a polymorphic machine, which configures all the pin heights.
Right.
But then the tooling is like a cassette you put in a cassette player, right? You put the tooling in, it reforms, reshapes, and then you take it out and then you use it for your application, whether that's composites, vacuum forming, casting. But you can actually stack these up to make really large molds, and then when you want to edit a certain area, you just take one mold out, because they're about the size of a shoebox.
But they can be put together to make larger larger molds. So in other words, you have a 3D scale, or you've got a
3D model, object file,
a model
STL.
that you want to design. How does this so do you all design the software that goes along with the machine that creates this, or?
Yeah, that's it. Yeah. So you would just upload a CAD model, STL file, object file to what we're now renaming. It was originally called our Z height translator software, but we're going to call it a surface point mapper, and that basically plots that array of pins onto a surface and works out all the Z heights of the pins.
Yeah.
And that's all done automatically, and then the machine will just reconfigure the tooling to match that shape. So you just, like for core cavity molding, for example, you just have top and bottom, so it'd work that out for you. And then if it's just one side of a model that you need, it would also do the same.
Tell us about, maybe to mention some, you mentioned the phones, maybe some, do you have any other like case studies that you can mention on companies or applications that you've seen this technology be beneficial for?
Yeah, sure. So,
and while you're talking about that, I'm going to pull up, I'm going to share a video while you're talking. Sure. So hopefully this is not distracting, but I do want to show that while you're speaking.
No, go for it. Yeah, it'll make my monologue more entertaining.
Yeah, for sure.
So obviously we've only really exposed our technology for about a month, right? So this is all really new to us, and discovering new applications like every day, like with people approaching us. But one of the really early ones that we never thought about we could do was like carbon fiber or composite products. So in one of the applications we already had was making diabetic footwear, and the outsoles, because they're all custom made basically. And they were like making lots of carbon fiber parts as well, and obviously they had to make molds for that, and the molds get stored or thrown away. It was very expensive and time consuming. So then we were like, well, hold on a minute, we could do that on our tooling. Why not? So then we made some like braces out of carbon fiber, and we sort of did a similar thing to what you just said. We because the mold is essentially infinitely reusable, so the mold cost is zero. Right. You can like vacuum form like a membrane over it, so create your plug essentially. Yeah. And then like a thin one that's not too expensive compared to making a whole mold. And then you can lay up your composite into that sort of piece of sacrificial plastic, for example. Right. So yeah, we made what we call like a carbon fiber AFO, which is a brace, like an orthotic brace for foot and leg. So that was pretty cool. That's cool. And you see here on this video, like we made like a face mask. Carbon
that's cool. I was watching that. That's pretty impressive.
So yeah, again, you don't have the mold waste anymore. You don't have to store it. You just reuse our tooling, our reconfigurable tooling. That's the mold of a bike seat.
And I mentioned like the speed, the time frame compared to, I know, additive manufacturing, 3D printing gets mentioned a lot for making tooling, but this process is a whole lot faster.
Yeah. And like I say, you don't have the waste as well. So eventually you have to store those molds or you have to throw them away.
Yeah. And these things can be used over and over. They're metal. Do you have to, I mean, in the process, are these heated at all, or are you using any kind of release agent?
No.
That's great.
They don't need that. Yeah. No, I mean, we're sort of expecting they should last over 10,000 cycles. That's what we're designing for. Yeah.
10,000 cycles.
Yeah. They'll need like intermittent maintenance, like the pins will break because you'll inherently like probably drop it or knock it on things, but sort of inexpensive repairs. But yeah, there's that's our expectation so far. Our internal tools have done thousands of cycles.
So how easy is it to replace? You have a pin, like you say, a pin that gets damaged.
Really easy. Yeah. That'll sort of be like a what do you call a consumable in a way.
Sure. Okay. And you mentioned, I asked, these aren't heated at all, right?
No. Okay. No. But you can heat. You can sort of put them in a heated environment.
I see.
We just need to run some tests, see if we can do up to like 400 degrees. Like composites and stuff. But for now, we're sort of satisfied that they can deal with 50 degrees.
Sure.
Curing. Yeah.
What kind of response have you all gotten?
Well, so we've only been to one major show since we've unveiled what we're doing, and that was the TCT Rapid show in LA. And the response was great. Like, my pitch to people walking past was, "Can I stop you for a minute? I promise you, this is the only different thing you've seen in manufacturing for years.
Of course.
If I'm wrong, I'll buy you a beer." And
that's an easy one.
I've not bought a beer yet, so
right.
It says people are really interested, and like what's exciting for us is all the applications that are coming out that we never even thought about, or didn't would have never known about. So yeah, people are pretty excited about it. We just need to hurry up and get on first sort of production run of machines done.
So you're featuring these. You mentioned at this show. What was the name of the show that you were?
Form Next in Frankfurt, Germany, and that's November. Yeah. Okay.
And I want to mention again the website. Josh is Fyous, right? And that's FYOUS.com. You guys do have a YouTube channel with some interesting. We've been showing some of the videos.
There'll be a lot more videos to come as well. So over the next few weeks, we'll be putting more and more sort of demonstration applications on there.
So it's pretty cool. How big's your team right now, and where are you guys working out of?
So working out of the UK, Sheffield, England, the home of stainless steel. And
good place to
be. There's 11 of us at the moment. So hopefully be growing, scaling fast as well.
Well, kudos to you guys and best of success. Josh Shires, he is the CEO of Fyous. You can find him again, fyous.com.